Hi, my name is Steve Demig. This is a presentation for my paper or project, which is called Data Mining the U.S. DOT Department of Transport Statistics on Aviation. It's for the Cloud Computing Capstone. This is task one. Overall purpose is to take the the data set from the DOT, kind of filter out the aviation data, the on-time airline data specifically, and take only the fields you want. This is a process called cleaning, and we're going to put that data, that clean data, into HDFS, which has you can't store near as much in the HDFS as you can on the disk. So you have to be able to clean the data, put it in there in a HDFS, which is a distributed database for all the members of the Hadoop cluster we're going to be using to process that data. The real important part about this slide is this URL right here, which is where all of the code used and all the results, all the documentation, everything can be viewed for this project. System setup and installation summary. The instance type I used was a C3 extra large. I used Amazon Web Services, of course. AMI ID is given. It's a Hortonworks 2.1 sandbox. 4 virtual CPUs, 7.5 gig of memory, 128 gig of instance storage. That's increased from the default to 50 gig. EBS volume ID is the snapshot of the BTS transportation data. I I created a volume from that and attached it to my VM, mounted it, and then cleaned the data using R, which is a statistical programming language. Also have installed on that machine Cassandra, which is a NoSQL database. Cleaning the data, as I said, the attached and mounted volume of data was ran through an R program, and then the R program stored that data into HDFS. Group 1 problems. These were kind of easier sorting type problems. I used Java on these, straight MapReduce. Java file was compiled and archived using the Hadoop Java C compiler and just regular jar utility. Then that jar was run in Hadoop using MapReduce techniques, and the results were stored in the HDFS. Group 2 problems. These were a little more complicated. It would have been very difficult to program these using MapReduce. Not impossible, but very difficult. So I used Pig for these. Pig has a SQL-like language, and it breaks that down into Java MapReduce programs that you could write if you wanted to, but this allows you to do it much simpler in a SQL-like, using an SQL-like syntax, and it takes care of all the MapReduce for you. Runs the job and then puts the result in the HDFS cluster as well. The trick here I did was I took that output and I ran it through a Python script to create essentially a bunch of insert commands in a CQL file, and then I ran that through CQLSH to load the Cassandra database with the results. I could not get the Pig to Cassandra interface to work. I tried and I could not get that to work, so this is how I ended up approaching that. Group 3 problems. Similarly, I used Pig here to kind of take the big data and compress it to filter it down to a smaller subset, and then I used R directly to do the analysis on this. It was a more complicated analysis for these, so R worked really well on that smaller subset of data. I found this technique very powerful to do this. Conclusions, I really enjoyed this. I struggled a little at first because I had a little problems with the image I was using, but I really had a good time doing it, and I was really wanting to. I took the data science specialization from Johns Hopkins, and I was really wanting. I found that R did not scale well, so I was really wanting to use something like Hadoop to do the heavy lifting on data, and then use R to do the finer analysis on it, and I think it worked very well. So it was a lot of fun, and things I could do a little bit better. I think the cleaning of the data, I don't think I did quite good. I think I'll be a little more sophisticated for task 2 on that. All right, so that's enough for the PowerPoint. Let's go on. One thing I wanted to mention here was that, like I said, all the code and all the results can be found, and documentation as well, can be found in Git. I give the URL in this presentation as well as the report, so feel free to browse that code and look at it, whatever you want to do with it. Now we'll move on to a little bit of a demo type thing. First thing I want to show is the R script I use to clean the data. We'll just more it out and take a look at it real quick. The real details aren't that important, but you can see it's just a regular R script. It uses a package called RHDFS, and it takes the gzip data, reads it, and then copies it over into HDFS. I ran that with a no-hup, kind of like this. No-hup R script clean.r. I won't run it right now because that'll take a long time to run. And I want to actually do some work on the data, but I'll show you that this is how you can run R programs from the command line, and you can do stuff with HDFS with them. You can see here, if you look at the no-hup.out, that this thing actually ran and produced output, and it was putting the data in HDFS. We can take a look at HDFS real quick. If we look at the on-time data directory that's in HDFS, get a listing there. We see all of the different filtered CSV files, which I call TXT, but they're still really a CSV file. And we can take a look at what one of those looks like. It's basically what it is. It ends up being about 13 columns of data. I could have compressed it a little bit smaller. A couple fields were duplicate, and like I said, again, for the next task, I might end up doing that. I might go a little smaller and clean things out a little bit better. But it worked pretty well to use R. R is real flexible and great with tabular CSV type data, so it worked very well. Next thing we're going to look at is the group 1 type problems. All right, take a look at these. Like I said, these were I can't spell. These were done using straight Java. So if you look, I have Java files in here, jar files that were created. I have a build directory that has all the class files in it. These require the output directory to be removed before you start the program, so I'm going to go ahead and do that. For these, I'm just going to work on a subset of the data so you can see that it actually works. I'm not working on the full set of data. That's just a disclaimer. I'm going to remove the output directory. Okay, and I'm going to run a simple, one of the top airports. I'm going to run that jar. It's going to tell me the top airports and just the test data that I'm using. So that's just like one file out of them all that's in the HDFS. Starting up the MapReduce jobs. It's running. MapReduce is batch, so nothing's quick with MapReduce, but this is only, like I said, a small subset on one file, so it runs pretty quick. There we go, it's complete. I'm going to take a look at that output. And we're going to see it lists the top 10 airports for that single file, which O'Hare is number 1. I think that's number 1 in all the data as well. Okay, next thing we're going to do is look at group 2. Okay, for these, I used the shell script. We can take a look at the shell script that I have for that. 200.1 .sh. We'll take a look. Just a simple shell script. Does some Hadoop initializations. Runs a pig script. Then runs this thing called pig to CQL, which takes the output of the HDFS command and creates like I said, a CQL file. And then it, I commented out where it actually runs the CQLSH on it, because I don't want to write this data because it's a subset of the data. I don't want to write that to Cassandra, but we're just going to output it to the screen. So we're going to run it. Okay, it takes a little while to run. Okay, it's finished, and eventually here it's going to cat out all of its results, which you can see. All right, so then we're going to look a little bit at Cassandra. So we're going to run CQLSH. All right, we're going to use my key space, which is just the key space I created for this. And we're going to take a look at results 1, which is a table that I used to load up the results from the first problem 2.1, basically. We're going to take a look at what's in there. You can see it actually loaded the data with all the output from the group 2.1 problem. We're going to quit that. We're going to move over to the group 3 problems, which similar to group 2, they use pig, they produce output, and they store in HDFS, but a little bit different is we take and we process it directly with R, and you can kind of see what's going on there with the group 3.2 R script. Oops, excuse me, I can't spell again. Okay, we're going to take a look at this R script, and it's just basic R. It doesn't do much, but it's a lot easier to do the stuff it's doing here than it would have been in pig. So now we're going to run this. We're going to run one of the queries from the problem, which is going from Dallas to ORD, or I think it's O'Hare again, and it's going back to Dallas on October 6, 2008. This runs pretty quick because it only runs on 2008 data, so that the group 3 problems were actually a lot quicker than the group 2 or group 1 problems, because you can subset the data a little. It runs, the MapReduce is done, now R is processing it. You see it produces a lot of output on the different flights you can take, both originating flights from Dallas-Fort Worth to O'Hare, and then terminating flights back from O'Hare to DFW. And that's really it. So, like I said, I had a lot of fun working on this project. It took a lot of time, I won't lie there, and I did run into a couple gotchas, but it was a lot of fun. So, thank you.